So till now we have discussed how to calculate the compound interest and the total amount when interest is compounded annually, semi-annually and quarterly. We did not discuss the formula to tell the compound interest and the total amount directly. So that is we are going to discuss now. We are going to discuss the formula to tell the compound interest and the total amount and when the interest is compounded annually. In this case, we'll discuss only about annually. In the next couple of video tutorials, we'll talk about when interest is compounded semi-annually and then quarterly. So let's say that our principal is P1. P1 is some amount and rate is R% per annum, and the rate, this interest is compounded annually. This is interest rate. So compounded annually means that your interest will be calculated for a period of 1 year. For 1 year, then another 1 year, then another 1 year, right? So let's say that this is first year. Let's say that this is first year. Your principal is P1. Your rate is R% per annum, right? And time period will be 1 year because it is annually. So tell me, what will be the simple interest for this first year? The interest that will be applied for this 1 year on this amount, that will be equal to P multiplied by R divided by 100 multiplied by T. So if we denote this simple interest by SI1 for this 1 year, so this will become P1 multiplied by R by 100 and multiplied by T, that is 1, so just leave it there. Okay, so multiplied by 1 means this thing only. Now tell me, what will be the loan amount? What will be the loan amount? Loan amount at the end of this first year. Loan amount will be P1 plus SI1. Now P1 is P1 and SI1 is P1 multiplied by R by 100. Okay, this can be written as, can you see, this is common, this is addition, this one term is P1 and here this is in multiplication. So applying the property of distributivity of multiplication or addition, you can write it as P1 within bracket 1 plus R by 100. Okay, now this interest, this loan amount at the end of first year will be the principal for the next year, that is second year. This will be the principal. So second year, this loan amount at the end of 1 year will be the principal. So the principal in this case is, let's say for the second year it is P2, and what will be P2? P2 will be this much, that is P1 1 plus R by 100. Now rate will remain the same, that is R% per annum, and time period will be 1 year. Now if you calculate the simple interest for this year, let's denote it by SI2, same formula, P multiplied by R by 100 multiplied by T. So P is in this case P2. What is P2? P2 is P1 1 plus R by 100 multiplied by R by 100, because this will remain there. This is P2 multiplied by R by 100 and multiplied by 1. So this will give back this value only. Now tell me, if this is the interest for this second year, period of 1 year, another 1 year, so what will be the loan amount at the end of this second year? The loan amount will be P2 plus SI2. What's P2? P2 is P1 1 plus R by 100. What's SI2? SI2 is P1 1 plus R by 100 multiplied by R by 100. Now if you look at this properly, then this is the addition sign, right? This term and this this is common on both the sides, in both these terms. So if you solve it, you'll get, if you take this common, this is P1 1 plus R by 100. If you take this common, then here you will have 1 plus, taking this common, so for this you will have 1, then plus this is taken common, you are left with R by 100. Right? Now this is P1 multiplied by 1 plus R by 100 multiplied by 1 plus R by 100. This can be written as P1 1 plus R by 100 squared. 1 plus R by 100 multiplied by 1 plus R by 100 means squared. So this is the amount for the second year, the loan amount at the end of second year. Now this loan amount at the end of second year will be the principal for the third year. Principal for the third year. So the principal, let's denote it by P3. So P3 is what? P1 1 plus R by 100 squared and R% per annum. Time period will remain 1 year. Okay, so if you calculate the simple interest for this for this year, let's denote it by SI3. So P multiplied by R multiplied by T. What's P? P is P1 1 plus R by 100 squared multiplied by R, that is R by 100, multiplied by T, that is 1 year. So P multiplied by R multiplied by T will give us this. What will be the loan amount? Therefore, what will be the loan amount? The loan amount at the end of this third year will be P3 plus SI3. Now P3 is P1 1 plus R by 100 squared plus SI3 is P1 1 plus R by 100 squared multiplied by R by 100. Right? Now if you look at this and this, these two are common in these two terms, right? So if you take this P1 and 1 plus R by 100 common, then you are left with, for this term you will have 1 plus, for this term you are left with R by 100. Now this is squared, this is squared because this is common here. Now this is P1 multiplied by 1 plus R by 100 squared multiplied by 1 plus R by 100. So you can write it as P1 multiplied by 1 plus R by 100 cubed. Okay, so there is a trend. What is the trend? The trend is that for the first year, you can write it here as this one as 1, right? This 1 means that if you solve it, you'll get back P1 multiplied by 1 plus R by 100 only. So for the first year, this is the loan amount, that is the amount at the end of 1 year. At the end of second year, this is the loan amount, that is you have 2 here. For the first year, you have 1. For the second year, you have 2. For the third year, you have 3. It means that for this principal, P1, rate R% per annum, and when the interest rate is compounded annually, if someone asks you that what will be the loan amount or the amount, final total amount at the end of nth year, let's say for the nth year, what will be that amount? Now n can be any integer value, right? It can be 2 years, it can be 10 years, it can be 11 years. So is there any formula? Yes, simply write it as P1 multiplied by 1 plus R by 100 and put this power n. What's n? N will tell you the number of years that it has been asked in the question. So if someone asks you for the 11 years, that what will be the total amount at the end of the 11th year. The total amount at the end of the 11th year will be, just put 11 here. If it is 20 years, put 20 here. This will remain the same, only this power will go on changing with the change in your years. So this is the formula for the total amount at the end of nth year, right? For the nth year. So if this is a total amount at the end of the nth year, tell me what will be the formula for the compound interest. Now the formula for the compound interest we know is that compound interest is equal to final amount minus principal amount. What is the final amount here? The final amount is this one. For the nth year, we are calculating for the nth year. Remember this one. So P1 multiplied by 1 plus R by 100 to the power n minus, what's P here? P is, that is principal. Final amount minus principal is the compound interest. This is the formula. So the principal in this case is P1. So here again you can see that this P1 is common in this term and P1 is common in this term. So if you take P1 as common, you'll get P1, and within the square bracket 1 plus R by 100 to the power n minus 1, right? Because P1 is common in these two terms. So this is the formula. The main thing is that you remember this formula. That is, if you remember the formula for the total amount at the end of the nth year when the interest is being compounded annually, you can easily find out compound interest, because compound interest is final amount minus principal. If you remember this formula, you can easily, derive this formula instantly at that time. So this is your formula for the compound interest for the nth year, for the compound interest, and this is for the total amount at the end of n year. Now, one important point: in some books you can find that this formula is actually written as P1 within the bracket 1 plus R to the power n. This is not divided by 100. Well, this is also correct. What's the difference then? Let me explain you with example. Let's say that the rate is 8% per annum. 8% per annum. If you are using this formula, simply put 8 here. If you are using this formula, then you'll have to write 8 by 100. This 8% means what? This is 8 by 100 only. So when we derived this formula, when we were deriving this formula, we actually used 8 by 100 from the starting. But if suppose you use only R and not R by 100, in that case you will reach to this formula. But both are the same thing. If you are using this formula, put 8 here. If you are using this formula, then put 8 by 100 here and you get the same answer. In the next video tutorial, we are going to talk about calculating the formula for the compound interest and the total amount when the interest is being compounded semi-annually, that is half yearly.